Good morning, everybody. Welcome to our webinar today, which is Charge Logic, Avoiding a Credit Card Data Breach. We want to welcome you, of course. We are so happy that you're here. I just wanted to introduce our speaker today. Jonathan Cooper is the president of Charge Logic. Charge Logic is a company that provides credit card processing software and solutions to the Microsoft Dynamics community. He's an expert in credit card security and has been creating PCI compliance solutions since 2006. So with that, thank you, Jonathan, for being here, and I will hand it over to you.
Great, thanks. So today we're going to be talking about data security and specifically PCI compliance as it relates to the credit card industry. And so we actually have quite a bit of experience in this area. We create a credit card payment application called Charge Logic Payments, and as part of the process of being allowed to sell that, we have to go through our own PCI compliance testing just for payment applications, which is extremely rigorous. It's called PCI PA-DSS, Payment Application Data Security Standards. We also run a payment service, a payment gateway called Charge Logic Connect. We actually have to go through a separate audit for that. And then just internally, we take credit cards as a business from our customers, and we have to go through an audit for that as well. So we actually have 3 audits that we have to undergo every single year, and so thusly we are actually quite familiar with the ins and outs of PCI compliance. And as part of selling a payment application, the PCI Security Standards Council asks us to try to disseminate a lot of this information to other credit card merchants. So we often give webinars like this to help to make it easy for people to understand exactly what their responsibilities are. So over the last few years, there have been quite a few large-scale data breaches. Many of them have made the news, and it has been a situation where lots of people individually have been impacted. Everything from Neiman Marcus to Living Social. Adobe was one of the biggest. There are very few in recent memory, though, that have been as covered in the media or as widespread as the Target data breach that happened around the holiday time of last year. So this was an extremely high-profile data breach, and the current estimate puts the number of customers impacted at 110 million, making it one of the largest in history. So as part of this presentation, I wanted to sort of go over what went wrong with Target and how can other companies avoid a similar fate. So with Target, as with most data breaches that we hear about, it's not really any one thing that they did wrong. It's actually a combination of factors that allowed attackers to sort of worm their way into the system. So it's not like they had the front doors wide open saying, come on in and attack us. It's more that there was sort of a maze that attackers had to go through, and there were openings at just the right places that they needed. So the first problem was that Target didn't really have good separation in their internal networks. Everything was sort of mixed together. What ended up happening was that, and this is sort of based on preliminary findings, that there were various vendors that Target gave remote access to in order to support systems inside the stores. And one of those systems was the HVAC systems that controlled things like the store temperatures, but also things like the refrigerator and freezer sections. And all of those have monitoring in them. And the vendor that was in charge of installing and maintaining those systems was given remote access so that they could make sure that everything was operating smoothly. It turned out that there was not sufficient separation between the networks that those systems were on and the networks that the point of sale systems were on. And when everything gets mixed together like that, there can end up being issues. So it's extremely important in a cardholder data environment to really define what pieces of the environment are ones that contain sensitive data, and to segment those into completely separate networks where there's no overlap. So isolation is really key when it comes to protecting credit card information. And that's actually part of PCI compliance, is to separate the systems that have cardholder data. It also helps you become PCI compliant because it allows you to have the vast majority of your network actually out of scope for PCI compliance. And out of scope means that the auditors don't even look at it. So if you've got two completely separate networks and one has credit card information on it and the other one has absolutely nothing to do with credit cards, it's going to make it easier to secure your systems because you're dealing with a smaller subset of your systems on the cardholder data side, and hopefully everything else is on the other side. Okay, so that mistake let attackers sort of get entry into the system, but once they were on the network, they didn't have the ability to actually get to the point of sale machines directly because they weren't able to remotely log into them once they were on Target's network. So that's where mistake number 2 came in. What happened next was that once they were in, they found that there were actually various pieces of software installed that were using the default passwords. So there were IT management and monitoring applications that were installed on Target's network that were helping to do things like deploy security patches and to make sure that all of the systems were up to date. That software application was installed using the default password. So anybody who was familiar with that particular program would know how to log into it and sort of take control of it and make it do whatever they wanted to. So using default passwords is another big problem with becoming PCI compliant. That's something you never want to do. So any application that you ever install, you want to make sure that you're not using the default account credentials, and you want to make sure that the passwords are always changed. So one diagram that is made available by the PCI Security Standards Council that actually maintains the data security standards that are required to be followed by any merchant that takes credit cards is up on the screen here. And this, the times that they put here, 0.077 seconds at the top versus 344,000 years. There may be some dispute as to whether those times are actually accurate, but in general, the information here is good. And what is actually, what makes a password really hard to crack is length. So you want to make sure you're not using dictionary words. So Big Mac is the example that they give, and the easiest to crack password. It's actually composed of 2 dictionary words. It's not a single word, but even so, it is easy to crack. And then all the way at the bottom, they have B1G, Mac, and fries. So they give that as an example of the most secure type of password, but I would actually take issue with that and argue that really the most secure password is one that's composed of a very lengthy, completely random set of letters, numbers, and special characters. And when you do that, there really isn't a chance that an attacker is going to be able to brute force crack that password. And that's what we're really talking about here. We're talking about brute force cracking, where attackers are trying all combinations of words, letters, numbers to try to get access into a system remotely. The problem with doing what they suggest here, actually, with this B1G, Mac, and fries, is that the attackers' dictionaries that they use for trying to brute force their way into various systems actually know all of those tricks. So they know that people will often replace I with a 1 or an E with a 3, and they actually make those, and entries into their dictionary. So making those replacements that we see very often in passwords doesn't really give you all that much extra security. What you really want to do is have a completely random long password, and length is key. So when I generate a password for an online service or account, I generally use the longest possible password that site will let me, or 16 characters, something along those lines. So then the question is, well, what do you then do with all of these random passwords? Because I want a different random password on every site. And that's one of the problems with Target, was that actually their vendor, their HVAC vendor, used the same password on all of their customers' accounts. So if this vendor was helping out Target with their HVAC system and they also were helping out Walmart, they would have some standard credentials. They would have a username that they used everywhere and a password that they used everywhere to help their customer service people be able to log into their customer sites. However, that's completely insecure, because once somebody knows what that default password is, they can then log into any of those customers' accounts. So as I'm saying, random passwords are really the way to go. There are three popular services that can help you with that. I use LastPass, and what that would then do is keep track of all of the various random passwords for all of your various sites and services. So when you do that, you then have the ability to have real security. And you don't want to use the same password at multiple sites, because if one then gets compromised, you want to make sure that an attacker couldn't then use that password to log into one of your other accounts. So long passwords, random if you can, and use a password manager rather than selecting easy to remember passwords. Okay, so we've talked about sort of networks not being isolated. We've talked about password management, but that actually then, those two things combined helped the attackers get into Target. They used that IT system that I was talking about that helped to distribute patches. They actually logged into it themselves and used it to install malware on all of the point-of-sale machines. And so then once they did that, those point-of-sale machines started taking people's swiped cards, PIN information, any information it could get its hands on, and started sending it out to servers in Russia. So it was exfiltrating sensitive cardholder data from Target's network off to some server hosted elsewhere in the world. So that's how the breach happened, but Target actually had a safety net. They used and paid for a service that scanned their network and alerted them as to whether or not there was a problem. And that service actually worked. They got a phone call from their service provider that said, hey, it looks like there's a lot of information leaving your network that looks atypical. We can't see exactly what it is because it's encrypted, but it's all getting sent to some server in Russia. And Target actually suppressed it as a false alarm. That company called the second time and said, we really think that there's a problem. Data is leaving your network and it's going to Russia. And again, Target suppressed it as a false alarm and ignored it. So mistake number 3 is look at your logs and listen to your monitoring software. Don't assume that just because sort of the worst kind of alert is coming up and that it's probably a false alarm. Always investigate alarms that you have, because that's why they're there. You install these systems and services to help you, and you want to really listen to them. So it was those combinations of factors that helped attackers get into Target's network, install malware on the point-of-sale machines, and then exfiltrate cardholder data, 110 million customers worth of data, to networks in Eastern Europe. So again, it wasn't really any one thing. It was a combination of factors, but making sure that you have really taken care of all of the various steps in securing your networks and your data can help make sure that something similar doesn't happen to you. And to help companies really prioritize, Visa has come up with a list of top 5 vulnerabilities that they see out in the real world that they want people to sort of address first and take care of first before they sort of deal with the rest of the rest of the problems that may exist. And Visa is in a unique position to be able to do this because before there was a PCI Security Standards Council, Visa actually maintained the data security standard that actually became the PCI data security standard. So they were one of the founding members, and Visa's payment application best practices and merchant best practices documents were actually used as the basis for today's PCI data security standards. So we're just going to go through this and look at Visa's top 5 because they still maintain this and they are still much in the know when it comes to how to help merchants avoid problems. So number 1 is storage of the CVV, track data, and PIN blocks. We actually see this with relative frequency with our customers. What they want to do is store that CVV number, that 3-digit code on the back of a credit card or the 4-digit code on the front of an American Express. So the purpose of that CVV is to tell the payment processor that the customer was present at the time that that transaction went through, whether it was on the phone, whether it was on a website, or whether it was standing in front of them in a face-to-face retail operation. The presentment of that CVV is supposed to indicate that the card is actually physically present. If you don't send the CVV, that's actually not a problem. The transaction will still go through. It's no issue. But some merchants really like to send that CVV. They think they're going to get a better processing rate, which typically is not true. Or, I don't know what they think, but they really want to store that CVV a lot. And it's absolutely against the rules to do so, and it actually breaks what the intent of that CVV is. So Visa says, number 1, never store that CVV. Don't ever write it down. If you have a credit card authorization form that you have customers filling out, don't have them write down the CVV. That number should never be written down, stored on your computer, stored in your database, anywhere. It's only to be entered at the time that a transaction is being processed and then immediately forgotten. Track data is similar. That's the data that's actually stored on the magnetic stripe on the back of a card. So if you're a retailer and you're swiping cards to transact, you're not allowed to store the data on there. You can keep it long enough to send it to the processor, and then you're supposed to forget it. With debit cards, same thing with PIN blocks, of course. You don't want to ever remember the PIN block from a debit transaction. Okay, so once we know this, we realize that we want to make sure that this data doesn't ever appear in any logs either. So what we see often is people saying, oh, well, we don't retain it, but when you actually go and look at the logs on their systems, you can actually see CVVs or track data in there. So you want to look everywhere and make sure that it's not appearing on disk at all, ever, not even encrypted. Okay, so number 2 is missing or outdated security patches. So in the case of Target, the malware that was installed on their point-of-sale machines actually was not caught by their antivirus. So in some cases, it is critical to have your malware completely up to date. In other cases, it doesn't matter, but Visa says, just to be safe, always have it up to date. And it's also security patches in things like Adobe Flash and things like Java. So those 2 vectors, Flash and Java, are currently the sort of the top ways that people get their systems infected. It used to be that the infections came in through the operating system. So Windows wasn't patched, and people were out there surfing, and they got themselves onto a website that was taking advantage of some vulnerability in the browser or in the operating system, and it installed malware on their computer that would then, install a keylogger, for example. So anytime you type in a credit card number, it would send that information off to China or Russia or wherever it happens to be going. But these days, it's actually not the operating system. Microsoft has done a relatively good job of making sure that there are new technologies in place that help to limit the attack surface of modern operating systems. So today, it's really things more at the application layer that are causing problems. And there are just vulnerabilities found all the time on almost a daily basis in things like Java and Flash. So you want to make sure that everything is always patched and up to date. So while talking about this, one of the things that's happened relatively recently is that Microsoft has ended support for Windows XP. What that means is that they're no longer producing patches for that operating system, or they may be producing patches, but they're not available to 99% of users. They're really only available to enterprises that are paying for extended maintenance. So what that means is that if you're not receiving patches for your operating system, you should not be using that operating system in a cardholder data environment, because it's not like there aren't new vulnerabilities being found, it's that they are being found and they're not being patched. And what's actually even worse is that there's a lot of shared code between Windows XP and more modern operating systems like Windows 7, Windows 8, Windows 8.1. And when Microsoft issues a patch for, let's say, Windows 7, it's because there was a problem found in Windows 7. And what the bad guys can do is actually take that patch and analyze it and find out what the problem was that Microsoft was fixing. So once they have that information, they can go back to Windows XP and see if that problem existed back in the days of Windows XP. And more often than not, it did, except it's actually not being patched for Windows XP. So what that means is that users who are using Windows XP are sort of having their systems exposed through patches to later operating systems to the bad guys. So using Windows XP in a cardholder data environment is not going to be PCI compliant, and is something that you're going to need to address sooner rather than later. Okay, next, we already talked about this, vendor-supplied default settings and passwords. So this is Visa's number 3 vulnerability that they want people to address, and that's one that Target may have addressed in many cases, but not all. And you really have to make sure that in all cases you're not using the default password. So again, here's that password 1, that's the most common password. You want to make sure that you're not using common passwords or default passwords on any services. And that includes things like hardware devices. If you have routers or wireless access points, you want to make sure that you're not using the default password that came from the manufacturer. Okay, so their number 4 vulnerability is SQL injection. SQL injection may be a little bit tricky to understand if you're not a programmer. So I found this XKCD comic that helps to understand it. So if we just read through it, we have a mother saying, answering the phone, and on the other end they're saying, "Hi, this is your son's school. We're having some computer trouble." And the mother says, "Oh dear, did he break something?" And the school says, "In a way." And the mother says, and the school says, "Did you really name your son Robert, quote, paren, semicolon, drop table students?" And the mother says, "Oh yes, little Bobby Tables we call him." And then what ends up happening, of course, is the school says, "Well, we've lost this year's student records. I hope you're happy." And the mother says, "I hope you've learned to sanitize your database inputs." So what's actually happening here is that the school obviously had some web-based system where they were entering student data. And when they entered in Robert Tables' name, who has all those special characters and actual SQL commands within the data, the database actually interpreted that as a command, and it dropped the student table. And that's what a SQL injection attack is. It's where a server is taking what should be normal user input, and an attacker injects SQL commands, database commands, into that input, and the SQL server interprets it as a command instead of as data. So this applies typically to web applications more than anything, but it's, again, Visa's number 4 vulnerability. So again, whenever you're thinking about developing a web application, just think of little Bobby Tables when you're deciding how to accept that user input, and make sure that you sanitize it and make sure that anything that goes from a user directly to the database runs through some code that makes sure that you're not sending commands directly to the server. Okay, and then their number 5 is unnecessary and vulnerable services or servers. So this one actually made me think of a picture like this. So this car has quite a few antennas on it, and they're probably all there for their own specific purpose, but you have to ask yourself, do they really need all of those services? Maybe one's a CB radio, one's a TV antenna, one's a remote control for an airplane. Who knows what it is? But the question is, do they really need all of those services, and is it going to impact their security? Is it going to impact, in this case, their visibility, let's say? So you have to think of what the trade-offs are when you have services running. So what we see happen is somebody will bring up a new server, and those servers come out of the box with sort of a default set of services installed. Maybe it has Windows file sharing installed. Maybe it has a web server installed. Maybe it has an FTP server installed. So the more services that you have running on a server, the bigger the attack surface is. So that what that means is that any vulnerabilities that are found in any of those individual services become an attack vector for someone to get into that server. So you want to restrict the services that you have running to only what you actually have a business need to be running, and that way you have very, you've reduced the attack surface as much as possible. Obviously servers are there to provide services, so running no services is not helpful, but running only the services that you actually have a business need to run is really the best you can do. So you don't want to use the defaults typically. You want to make sure when you bring up a new server that you've shut down anything that you don't actually need. Okay, so we then like to take a look at sort of various sales channels and talk to our customers about what exactly they can do and what their risks are in terms of PCI compliance and data security. So let's take a look first at what the biggest risks are for e-commerce merchants. So the problem with e-commerce and the beauty of e-commerce is that you have a web server that's out there, and it has to be exposed to the internet. It has to be a public service that really anybody can come to and place an order. So that's, like I said, the beauty of it. So you don't need to have customer service people. You don't have to have somebody come to your location. Anybody in the world can come to your website and place an order. The problem with that is that anybody can come to your website, and that includes attackers. So the very nature of an e-commerce website is that it's exposed. And that exposure sort of allows people to attack it indiscriminately. So what that means is that any credit card numbers that are handled by your e-commerce server are ripe for theft. You don't want to have an attacker get into your e-commerce server and you not know about it, and they just have software running there quietly in the background that's siphoning off all of your customers' sensitive data. So we really believe that web applications should never be storing credit card data. There are also ways to have websites not only not store data, but never see it or touch it in the first place, and that's something called hosted payments that we're going to talk about in a few minutes. So we truly believe that e-commerce websites have no business storing or even usually handling credit card data. The risk is just too big. For mail order, we've got a problem where credit card numbers are written down on order forms. Again, there's really not much you can do about that. If you want to take an order by mail and you want someone to pay by credit card, they have to let you know what that card number is. So of course the risk is you've got all these physical pieces of paper floating around your office that have sensitive data on them. So anybody could walk in, cleaning people, the mailman, whoever is coming into your office sees stacks of forms with credit card numbers on them, and it's easy to just pick one up and walk off with it. So what you want to do is implement document retention policies. You don't want to have a stack of 1,000 pieces of paper with credit card numbers on them, because that's relatively easy to walk off with, and then it's a big payoff. The other thing is that we are going to talk about tokenization in a few minutes, but tokenization is a great way to get credit card numbers in, have them sort of briefly or momentarily, and then turn them into a token that is then not dangerous at all if somebody were to get their hands on it. You want to maintain physical security and visitor identification. What that means is you want to have employees have badges or visitors have badges or something. So if you're in an office where not everybody knows everyone, you want to be able to quickly identify who is not an employee or who doesn't belong. And then there are also hosted payment solutions, again, that we'll talk about in a few minutes that may apply to mail order type scenarios. Next, we have call centers, and it doesn't really even have to be a big call center. It could just be a company that takes orders by phone. But the biggest problem here is when you have the ability to record phone calls. So people often don't think about this, but when you call into a company and they tell you that the call is going to be recorded for quality assurance, if you're reading your credit card number at any point during that call, your card number is probably going to end up in a recording on disk somewhere. And there is absolutely software that can siphon off those recordings and scan through it and use voice recognition and identify what the credit card numbers are. So there's an issue here with recordings in plain text, or where the recordings are being backed up and those backups are being mismanaged or not being kept track of. So what you want to do is either use call center software that is able to identify itself scenarios in which credit card numbers might be read and not record that portion of the call, or maybe use one of these hosted payment solutions, again, that we'll talk about in a few minutes, that basically involve the customer typing their own card number into a secure channel. Okay, so now we're going to talk about risk mitigation, now that we've talked about all the various risks. And when we talk about risk mitigation, really the best thing to do is to look at the PCI Security Standards Security Standards Council Data Security Standards, so they call it the PCI DSS. So if you go to PCISecurityStandards.org, there's a section there for merchants where you can then download the standards. So originally published in 2005, we're now at version 3, and this standard is backed by all the major card brands. And these standards really apply to all businesses that have anything to do with payment processing, all the way from the merchant who's accepting a payment to the processor who's actually transferring the funds. The other thing to note is that this is a private sector standard. It's not enforceable through legal action. It's through contract. So it's not like you're breaking the law if you're not following PCI DSS, but you may get yourself sued if you're not following it. So the sort of general outline of what the PCI DSS looks like is shown on the screen here. So there are sort of 12 major requirements, and then each of these have, many sub-requirements. So the thing is, multiple pages long. But in general, what we want to look at are these 12 things. So one is, the first section is building and maintaining a secure network. And we've already talked about both of those things. So that's, relatively easy to understand. 3 and 4 fall under protection of cardholder data. That means using a payment application that has gone through the Payment Application Data Security Standards testing. And you can find those at PCISecurityStandards.org, and they're listed under payment applications. So any application that you use to process credit cards, you want to make sure is listed there. And then that's going to help you meet requirements 3 and 4. We talked a little bit about antivirus and developing secure systems and applications. So you want to maintain a vulnerability management program. Access control. So we talked about visitor badges, but you also want to make sure that people who are using computers in that cardholder data environment have their own logins. So we see all the time, people setting up a point of sale, and they have a user called POS1 or POS2 or POS3, instead of having individual users logging in as themselves. When you use a shared login, you lose all ability to audit. So you want to make sure that each person has their own identifier that they log into the system with. You also want to restrict physical access to cardholder data. So that may mean putting your servers in cages so that people can't get to the servers themselves. If it's pieces of paper, you want to make sure they're in a locked filing cabinet and that you have sufficient physical security on your building. Monitoring and testing. So you want to make sure that you have logging turned on wherever it's available so you can see who is accessing what. And you want to have your systems tested. And we're going to talk about that in a few minutes too, about what that testing looks like and what the requirements are. And then number 12 is maintaining an information security policy. So this is actually not really even a technical thing. It's more of maintaining documentation within your business about what your business is going to do if in the event of a data breach and what your business is doing to prevent a data breach. So it's something that you really need to involve multiple departments in your company in, both IT and executive and financial and whatever other departments you deem are necessary. So yes, this does seem like a lot, but all merchants are actually required to comply with this. And so that's another question that we get all the time is, do I really have to comply, or do I really have to follow these guidelines? And the answer is absolutely yes, you do. So if you take credit cards, you are required to follow this PCI data security standard. Now, when it comes to whether or not you need an audit, we can look at this chart that's put out by Visa, but it's also on MasterCard's site and the PCI Security Standards Council site. So essentially, the rule of thumb is that if you process more than 6 million credit card transactions in a year, you are required to have an on-site audit. So that really puts it in the realm of sort of the biggest retailers that are going to have more than 6 million transactions in a year. However, what you really need to note is that that second paragraph there, any merchant that has suffered a hack or an attack that resulted in an account data compromise is also required to be in that level 1 category. So that means that if your systems are not up to snuff and you lose any cardholder data and there are data breaches or compromises that the card companies attribute to your business, you're automatically put in that level 1. And that can actually be relatively devastating to a small business. These audits are not cheap. And if it's an audit that's being required by the card industry or by your payment processor, it's going to be expensive. So you want to make sure to keep yourself out of that level 1 category if you possibly can, so that you're not required to have annual on-site audits. The other thing to note here is that in all categories, a quarterly network scan is actually required. So what you're going to need to do is contract with what's called an ASV, an approved scanning vendor, to just run some simple tests against your network from the outside to make sure that you're not running any vulnerable services. And that's something that has to be done on a quarterly basis by any company that takes credit cards, no matter the size. And it's actually extremely affordable. Okay, so in case we haven't talked about this enough already, why comply? You want to comply because it will cost you not to. So every year, your bank probably sends you a questionnaire, a PCI compliance questionnaire that you're required to fill out. And if you are not in compliance, you need to state that and attest to it. And if you are in compliance, you need to state that and attest to it. If you're not in compliance, your bank is probably going to start charging you a non-compliance fee on your monthly credit card merchant statement. It's something that maybe you're paying already and not even knowing it because those statements are so complicated, who reads them anyway? So you're going to want to look and make sure that you're not being charged a non-compliance fee today. And if you are, you need to get yourself into compliance so that you stop paying that fee. Depending on your size, those penalties can range anywhere up to $100,000 a month if you're a big merchant. So you want to make sure that you're not paying that fee. If you're found to be not in compliance and you have a data breach, you're going to be required to pay fines. And the fines typically range in the area of $100 to $200 per lost credit card number per day that it was lost. So those, again, can add up quickly if you're losing hundreds, or in the case of Target, millions of credit card numbers. So you want to make sure that you are in compliance and that you are taking care of your data security so that you don't end up in a boat where you're paying gigantic fines. Okay, so part of maintaining this compliance is, we like to think of is broken down into sort of three sections. It's protecting your cardholder data while it's at rest, protecting it while it's in transit, and then protecting it when it's being viewed. So when we talk about protecting cardholder data at rest, that means when it's being stored in your system, you make sure that you have appropriate data retention policies, that you are not storing any credit card numbers themselves in the clear. You always need to store them encrypted. You're never storing CVVs at all, not even encrypted, and that you actually can store things like the cardholder name and expiration date in the clear. So just so that you know, it is allowable to encrypt the credit card number and store it. However, not storing card numbers is better than storing encrypted card numbers. So that's just, to sort of put things into perspective. It's also now a requirement in the later versions of PCI to implement strong data key management policies. So the keys that are actually being used to encrypt the credit card numbers, you have to manage those keys appropriately so that they don't fall into the wrong hands. So key management is actually part of PCI compliance now. Okay, so we've talked about data at rest. That means when it's being stored. Now we're talking about data in transit. That's data when it's actually being moved across the wire. So you want to make sure that you always use a secure channel to send credit card numbers. And that is typically going to be when you're sending them from your point of sale system or from your ERP system to your payment processor for processing. So you want to make sure that always goes over a secure channel and that you're not doing things like writing them to disk in the clear and then uploading them as a file or something like that. So our software Charge Logic Payments always sends data out under a secure channel. We use TLS, Transport Layer Security. You want to make sure that you never email a credit card number. You never want a customer to email you a credit card number. You never want to email a credit card number to one of your vendors. Email is not for credit cards. The two just don't mix. If you are using wireless networks, you want to make sure that you're using the newest wireless encryption mode, WPA2. That's all that's allowed under PCI. WEP, which is the oldest wireless encryption, is no longer permitted under PCI data security standards. It can be cracked in under 5 seconds. So only WPA2, never WEP. And then protecting cardholder data visibility. So what that means is that you can show credit card numbers if someone has a business need to know, but in general, your typical user should not have access to your customer's credit card data. So what you want to do is deny access to that data by default and then grant it when it's needed rather than the other way around. So it's, just like all things with security, you want to deny by default and then grant access when necessary. Okay, so the key here when we talk about PCI compliance and how to achieve it in a cost-effective way is limiting scope. Now, what does that mean? Limiting scope means that when you go through your PCI audit, whether it's an on-site auditor coming to you or whether it's your annual self-assessment that you're required to complete, you want to make sure that the areas of your environment that fall under the direction of PCI are as small as possible. And that's what we mean by limiting scope. And you can do that by consolidating payment applications onto dedicated platforms. That means that if you have 3 different websites that all take payment data, don't have them spread all around on different servers, really put them in one place, and then you can just work to secure that one server rather than tripling your work. You want to make sure, again, that your network is segmented. So any place where you have credit cards on your network, you want to make sure that that's separated from sort of your public places, maybe your phone system, for instance, or your voicemail system. You don't want to have to secure that like you're securing your point of sale. You want to identify third-party service providers who handle your credit card data. You want to make sure they're PCI validated. You want to make sure that any software that you're using is PCI validated. And you can check that at PCISecurityStandards.org. If they're not, then you're going to run into a problem. So you have to make sure that any software that you purchase is listed at PCISecurityStandards.org, or your payment processor is not going to issue you a merchant account. And then there are newer technologies that help to reduce the risk even further, and those we've briefly touched on, and we're going to go into a little bit more depth right now, is tokenization and hosted payments. So first let's talk about tokenization. Tokenization is a relatively new technology that allows you to take a credit card number, send it off to a service provider, and they store the card number for you and generate a token that's not derived from the card number. So it's not like it's an encrypted version of it or a hashed version of it. It's just a random number that they assign to that credit card number. And then what you store in your system is the token. So from then on, when you want to use that card number, let's say your customer places another order, or let's say that you have a subscription service that you're charging their credit card every month for, you can then charge them using the token and not their card number. And what that means is that you're never storing in your system any credit card numbers at all. So if your systems were to be compromised and someone were to steal your database, they're not going to get anything that's useful. They're only getting tokens, not card numbers. Now, there are some hidden costs to consider here. One is that a typical tokenization scenario requires you to use something called a payment gateway. A payment gateway sits between your software and your payment processor and sort of manages the interchange between the two. And you want to make sure that you know that you're going to be paying for that service. A payment gateway typically charges a monthly fee and then a per transaction fee. And when you use tokenization with a payment gateway, all of your transactions have to go through that gateway because they're the only ones who know the translation between token and card number. Some of them even charge for card storage, so that's something you're going to want to ask about if you are looking at tokenization providers. We actually have our own tokenization service built into the ChargeLogic Payments product called Secure Remote Storage that works a little bit differently. We like to think of it as like a hard drive in the cloud where you can still communicate directly with your payment processor. Transactions don't go through us, but we store your card numbers for you. So it's really more like a storage service than a gateway service. And we don't charge per transaction fees either. So you want to take a look at what the field is and look at your options. Okay, hosted payments. Hosted payments are a technology that's typically used on the e-commerce side where your e-commerce site is not directly taking the credit card numbers itself. PayPal is a great example of hosted payments. With PayPal, you put together your shopping cart on the e-commerce website. When you're ready to check out, you click the Pay with PayPal button, and the site sends you over to PayPal to complete the payment. So that site is actually not ever privy to your credit card details. They never see what card you use. They never have your credit card number, and it never goes through their server. Now, there are pluses and minuses to that. One plus is, of course, that it is sort of the ultimate in security for your website. But the drawback is that it can have a negative impact on your customer's sort of checkout experience because you're no longer in control of the whole thing. So we actually have a service called ChargeLogic Checkout that offers that redirect option, but we also offer what we call a hosted payment window that you can actually embed into your website. So you see the picture on the right. This is another option that is possible. So if you look at the picture on the right, you see the website, but the fields that you're entering your credit card number into are actually not hosted on the e-commerce site. They're hosted on our site. So when you use hosted payments, you can have the option of a full redirect or embedding the credit card fields from your service provider into your website for sort of a more streamlined user experience. Okay, so what you should have gotten here is that minimizing your risk is really one of the best ways to become PCI compliant. So when you do that, we're going to provide a checklist that is going to help you through the process, and that's going to be on the next slide, and that should be available to you after the presentation. So when you look at that checklist, you want to think about which pieces you want to manage internally. Often PCI compliance, like I said before, is sort of cross-departmental. It's not something that the IT department can just run off and do. That you have to involve finance, you have to involve operations, you have to involve physical building security. Everything and everyone has to be involved with PCI compliance. You want to really take a good hard look at where you can limit the scope. You can use various hardware and software solutions to help you do that. That may mean outsourcing your cardholder data environment. Maybe you only take credit cards over the web, and maybe you want to host your website somewhere else, not in your office, and that sort of gets that off your plate. And then you want to take a look at areas that you should really have a third-party handle for you, areas that you may not be comfortable dealing with yourself. And then finally, one thing that we recommend to merchants who are not PCI compliant at this stage in the game, which is sort of years into when they were supposed to be, you may just want to hire an auditor to come in the first time and help you. Like I said, it can be extremely expensive, and it's not something that you would want to be obligated to do every single year. But to make that investment one time, to have an auditor come in and help you get your systems on track and get over that hump one time is extremely helpful. And then once they've helped you do it once, maintaining should not be too difficult to do on your own. So hiring an auditor, and you can, again, find a list of them at PCISecurityStandards.org. They're called QSAs, Qualified Security Assessors. You want to find a QSA that can help you get PCI compliant, and then once you do that, you can sort of maintain it on your own. And if you need recommendations, we've actually worked with quite a few, and we'd be happy to share that with you. So here's the checklist that that we've put together. So first, we have identifying what category you as a merchant fit into and what your obligations are. Next, you want to limit your scope and implement something like tokenization or hosted payments to help keep your website, for example, out of scope for PCI compliance, because securing a website is one of the hardest things that you would have to do. You want to document your various systems and procedures, particularly if you're hiring an auditor to come in. You want to make sure you have all your ducks in a row before they start looking at things, and you want to make sure that you know your systems when they start asking questions about them. You have to contract with an ASV to perform those quarterly scans. Everybody has to do it. So we use Qualys ourselves, and it works great. They just send you sort of a quarterly report, and everything shows as in compliance. It's not very expensive. You want to identify who's going to do the audit. You have to do it every year, and it could be you or a QSA. Again, if you've never done it before and you're not in compliance, hire an auditor if you want. It might be easier. And then from then on, you can probably do it yourself unless you're in that category 1 where you're required to have an auditor come in every year. Next, just perform the audit. Go through all of your systems, answer all the questions, and what the audit basically involves is it's a checklist, and it asks you question after question after question about your systems, and you have to say whether or not it's in place or not. Usually no one passes on the first try, so you've got to next remediate, and that may mean moving things into a separate network. It may mean putting locks on some doors. It may mean a variety of different remediation measures, but you're probably going to have to make some changes in order to become compliant. And then finally, you have to submit your attestation of validation, an AOV they call it, to your payment processor every year so that they know that you're in compliance, and that's how they know to take that non-compliance charge off of your monthly merchant statement. Okay, so does anybody have any questions?
Of course, this is Abby from ABC. That was a great presentation. Of course, if you have any questions, you can type them right into the question box there. They don't show up for everybody, but they do show up for my screen. So I would be happy to read off any questions that we have. Well, it looks like that was such a great presentation that we don't have any questions.
Okay,
So
great.
Jonathan, any closing thoughts or remarks? And also I just wanted to remind everyone that they would be able to see a recording of this entire presentation on our website. That's abc-computers.com. And Jonathan, I'll turn it over to you for closing remarks.
Yeah, sure. So, my email address is up on the screen here. If you have any questions or you want to ask something that's specific to your company that you don't want to share in a public forum like this, absolutely feel free to email me. If you want recommendations for who to use for your scanning or for your audit, I'm happy to share those as well. We've used quite a few, and there are better ones and there are worse ones. And just on that topic, if you start talking to auditors and they try to scare you, talking to you about fines that, if you don't use them, they're going to turn you in, you absolutely don't want to use them. If they quote you a number that seems ridiculously high, you can probably shop it around and find somewhere else. When we were shopping around for our auditors, we got quotes between $5,000 and $50,000 for the same exact service. So you want to make sure you shop it around, find an auditor that you're comfortable with, and someone that can come on site and do the work. So thank you all so much for your attendance, and I really appreciate the opportunity to present.